Welcome to The Explainer. You know, we love to take complicated stuff and make it super simple. And today, we're going deep into the world of electronics to find a tiny, silent protector that, honestly, keeps our whole modern world from frying itself. So what is it? What's stopping your washing machine from just zapping its own brain every single time the motor kicks off? Well, the answer is this little unsung hero in the electronics world. And in this explainer, we are going to get right into what it is and, more importantly, how it does its super critical circuit-saving job. All right, so first things first, let's meet the villain of this story. We're talking about a massive, super destructive voltage spike that happens in like the blink of an eye. And it has a pretty cool name, inductive kickback. So what is an inductive kickback, really? Well, anytime you cut power to something with a coil, like a motor or a solenoid, that magnetic field it built up has to go somewhere. It collapses instantly. And that collapse unleashes this violent surge of energy with nowhere to go. The best analogy is a water hammer in your pipes. You shut the water off fast and you get that bam. It's that same kind of sudden, powerful, and really damaging jolt, but with electricity. And I'm not kidding when I say this kickback is powerful. We're talking about a voltage spike that can hit 8 to 10 times this circuit's normal operating voltage. That is absolutely enough to just obliterate sensitive electronics. Your microcontrollers, your logic boards, toast. Okay, so how on earth do you tame this electrical beast? Well, let's bring in the hero of our story, designed for this exact purpose, the RC suppressor. You'll also hear it called an RC snubber. The magic here is that it's this awesome two-part tag team. Think about it like this. First up, the capacitor. It acts like a shock absorber. It just jumps in and soaks up that initial energy spike, really slowing down how fast the voltage can rise. Then, once the capacitor's got it under control, the resistor tags in and its job is to safely get rid of that stored energy, turning it into a tiny, harmless bit of heat. It's this perfect one-two punch that just completely neutralizes the threat. And this whole tag team approach, it gives the RC suppressor some killer advantages. You get a really, really smooth reduction of that surge. It's the standard choice for AC coils. And here's a big one. It has almost no effect on the dropout time, so your relays switch off just as fast as they should. But maybe its biggest win is durability. These things are built to last, which makes them perfect for heavy-duty industrial gear that's switching on and off constantly, all day long. Now, the RC suppressor isn't the only game in town. It's not the only guardian out there. Let's bring in another really common component that does a similar job and see how they stack up. I'm talking about the MOV, which is short for Metal Oxide Varistor. So here's the thing. They have two totally different philosophies. An RC suppressor is all about damping. It's like a shock absorber for the electrical wave. It absorbs the energy and just smooths it all out. An MOV, though, it's all about clamping. I love this analogy. It's like a bouncer at a club. It lets all the normal voltage folks through, no problem. But the second a big voltage spike tries to get in, bam, it gets clamped and chopped right off at the door. Two very different ways to solve the same problem. Okay, looking at this chart, one of the biggest differences, and this is really key, is their lifespan. An MOV, well, it takes a hit every time it does its job. It degrades a little with every single surge, which means it has a finite life. The RC suppressor, though, it pretty much doesn't wear out. Its reliability is crazy high. And that difference right there tells you almost everything you need to know about where to use each one. So what's the takeaway? It's all about picking the right tool for the right job. You grab an MOV when you need protection from something big, nasty, and unpredictable from the outside, like a lightning strike nearby or a spike from the power grid. But for the predictable, constant switching that happens inside a machine, like an industrial relay, you want the durable RC suppressor. And for supercritical stuff, hey, why not use both? You get that high energy clamping and that smooth damping. Best of both worlds. Okay, so you might be thinking this is all just for, big industrial machines. But you'd be surprised. These little components are silently protecting stuff you use literally every single day. Let's take a look at where you can find them. I mean it, they are everywhere. They're inside those big, programmable logic controllers on the factory floor, protecting the sensitive brains from all that electrical noise. They are absolutely on the circuit board inside your washing machine, your dishwasher, your air conditioner, and hey, for any audiophiles out there, they're even in your amps and mixers, preventing that annoying pop when you switch something on or off. They're pretty much the invisible heroes keeping our power clean. All right, so what happens when one of these little guardians fails? They're not invincible. And more importantly, how can you tell it's failed? Let's dive into a little bit of troubleshooting. Okay, for an RC suppressor, one of the biggest telltale signs is actually visual. If you see little blue sparks, arcing right at your relay contacts when they open up, that's a huge red flag. It means the snubber isn't snubbing. So to be sure, you grab your multimeter. A good one should show infinite resistance, or OL, on the screen. Then you switch to the capacitance test, and that number better match what's printed right there on the component itself. MOVs, well, they go out with a bit more of a bang. They're designed to be sacrificial lambs, right? They die to save the rest of the circuit. So when they fail, they tend to leave a lot of evidence. You're looking for obvious burn marks, maybe cracks, or even a hole in the casing. Oh, and you can't miss that burnt electronic smell. And if you put a multimeter on it, it'll read as a dead short.
And this really brings us to the most important thing to remember when you're testing these. It doesn't matter if it's an RC suppressor or an MOV. A healthy one, under normal conditions, should look like an open circuit to your multimeter. That means you should see infinite resistance. On most meters, that's just going to show up as OL for overload or open line. Simple as that.
So think about it. Every single click, whir, and hum you hear from your devices, that's a tiny battle being fought and won against total electrical chaos. And knowing about these little components, well, it gives you the power not just to fix your gear, but to really appreciate the incredible invisible engineering that's keeping our world running safely, one voltage spike at a time.